Okay, is it quarter to? I guess we'll go. This is usually an hour and 15-minute talk, so I'm probably going to have to leave out all my horror stories and scare stories and urban myths, so I'll just keep to the bare facts. So my name is Godfrey Nolan. I run a company called Resell LC, which is based out of Detroit, Michigan. And it's kind of important because my goal is different because I'm a business owner than it may be as a developer. So I'm going to talk about Agile Swift and what that means. So our agenda is basically this. Although it would be obviously a Swift agenda as opposed to just an Agile agenda, what I'm trying to do is I'm trying to automate the entire stack here. I'm trying to automate unit tests, I'm trying to automate API tests. I'm going to do GUI tests, so it would be XCTest, whatever you want to use in the middle, we'll talk about that in a bit, and then XCUI. And the idea is that we want to keep the manual test to a minimum, and we want to make sure that this is automated on a continuous integration server. We use Jenkins, but there's no reason why you can't use other things too as well. The reason we use Jenkins is because we do Android and iOS and web development in the same shop, so we do everything in the same Jenkins. So goals are important, so there's lots of different goals. So like I said earlier, I'm a business owner, so my goal is to make sure that we keep the business. My goal is to make sure that when we start development, that when we're in that nice happy phase, when the customer's all happy with us, I want to make sure that at the end of the development that they're still in that happy phase. I want to make sure that my developers are doing what I think they're supposed to be doing. They should know what the rules of engagements are. But just as importantly, there's objectives, there's goals from the developers. So the developers want to make sure that they're in an environment which is not aggressive. They want to know that they're in an environment where they know exactly what they're supposed to be doing. So what we do is we provide them the tools, static analysis tools, for example, SonarQube, we'll talk a bit about that. And that allows people to know what's kind of expected for them. And then you as an audience, you have goals too as well. So maybe you want to set this up as well, so you want to learn from our lessons learned. I've got a lot of detail in this, and I'm not going to read out most of the detail, but the slides are up there. I'll tweet out the address at slides.com/Godfrey Nolan if you want to find it, and follow along as you go. But there's a lot of detail in here, so for your goal, what I want you to be able to do is to be able to go away from this and then learn from all the hassles that we had to go through in order to get Jenkins up and running. And Jenkins, to get it up and running in an iOS environment, can be really difficult. And there are certain things that we do, and there's one or two blog posts that I'm going to point out that will make your life a hell of a lot easier. So I think that's all the goals. Oh yeah, and my customers have goals too as well. So they want to be able to have something that is basically, works for whatever features that they've defined. So in a nutshell, what we're trying to do, we're trying to catch more mistakes. We're trying to confidently make more changes. So we want to be able to move from, just saw a talk in there next door where they move from core data to realm. So we want to be able to move from core data to realm. And we want to make sure that we have enough unit tests. We want to make sure that we have enough GUI tests that we're able to do that and still have the same functionality that we had before we started moving. We want to have built-in regression testing so that when we make a change to any of the code, we want to make sure that we don't introduce any weird side effects. And then this is the thing that we don't really talk about much in software development, but extend the life of your code base. How many people here have worked on a project where somebody said, you know what, it would be really so much quicker if we just started again from scratch? Have you all had that experience? I think we all have. There are ways to stop that, and some of the ways that you can stop that is that you can use static code analyzers. I'm going to talk about SonarQube, but there's others out there as well. And you can see if your code has got a lot of technical debt. It will tell you pretty quickly up front whether you've got a lot of technical debt or not. And you can address it before it becomes an issue. You can address it where it's days or weeks instead of months and years, because once it starts to get into weeks, once it starts to get into years, and you're just never going to do it. You're probably going to do it in Swift 5, Swift 6, you're going to wait for whatever comes along and then make the jump and move to something else. And me as a business owner, I want better predictability and reliability. I want to make sure that as we're using Scrum in our 2-week sprints, that I don't necessarily want to have more features developed every week. I just want to have pretty good idea about how many features, how many points are going to be done each week. So if it's 17 this week and it's 16 the next week, that's great. But if it's 50 one week and 4 the next, then I know that something's wrong, and then we have to have a look and see how we can fix this. And then reliability. You want to make sure that because I work for a services company, so we do mobile apps for lots of different people, and I want to make sure that what we're delivering is reliable and that it doesn't have any weird side effects, because we do our regression testing. So that's really, what I did is I was trying to come together with all these ideas of all the architects that we have in our company, and I put it in a book, and basically we've just been working on it ever since. I'm trying to make it better. So this is just a template for yourself. So this is the Minecone pyramid again, but it's showing what we're doing for in the iOS space. We have XCTest for unit tests. We have Postman, but Postman is for API tests. I find that a lot of the mobile apps that we do, a lot of what happens is that we don't control the backend API. It's somebody else's API. We used to do a lot of telco work, so it'd voice over IP, be a SIP server or something we'd be talking to. And we get a spec for the API, and I'm sure you guys have all come across this before, where you get a spec for the API, you code to the API goes into production, and it's nothing like the spec. So what do? So basically what we do is we have a lot of tests, API tests, so we remove the finger pointing. Because really that's what we're trying to do. We're trying to get our developers into an environment where they're not getting aggressive, they're trying to be creative, they're trying to get stuff done as quick as possible. And one of the ways that we do that is that we look at things and go, every time we do an app and there's a third-party API, there's always a fight over whose fault it is. So if you use Postman, or Rest Assured is pretty good too as well. Rest Assured is great if you have to show the code to somebody else, because it uses the given when then format, the Gherkin format, the BDD. So that's pretty cool too as well. Or we use Postman a lot too as well, where we write the tests in Postman, we export it into JSON, and then we use Newman, which is just a module that you use with Postman, which allows you to run it from the command line, so then you run it in your CI server, Jenkins. And if it fails, you know something's changed. And fairly quickly you can identify whether it's the API developers, the third-party vendor, or whether it's yourself. And then you can basically call the right person, as opposed to start to say, hey, is this our fault? We already know whose fault it is, because the build's broke. So I'll just go through real quick how to set up a simple unit test. What I'm going to go through is I'm going to go through our stack. At the end, I'm going to talk about a sample app that I put up on GitHub if you want to play with it. It will use all the different things that we're talking about during the talk. Okay, so in order to get unit tests going, check the checkbox for include unit tests. This is just a really basic calculator. The only thing that I've done here is that I've moved the code out into its own code file, so I don't have my model code in my user interface. So if I want to use unit tests, I want to make sure that it's in its own Swift file, so we can do it from there. And then if I want to start a test, really all it is straightforward. I have all the basic assertions that you would know from the past. So there's XCT assert, just making sure that it does add, it does subtract, it does multiply. The only thing I would do slightly different here in the divide is put a guard in there to make sure that it handles division by 0 appropriately and doesn't crash the app. It's really straightforward to do unit tests. Are people doing unit tests? Are you guys doing a lot of this stuff? Okay, I got asked the question because I ask this all the time. What kind of code coverage are you looking for in your unit tests on iOS? Is anybody up near the 70-80%? Oh, I saw one. We do lots of audits. We go into people and have a look at this. We find that a lot of the time what happens is that people say they're doing unit tests and they're basically not measuring the code coverage. I don't care if you have 100% code coverage. I really don't. I don't care if you have 80%, 90%, 70%. I want you guys to find a metric that you feel comfortable with, that you think you can get regression tests going. Because a lot of this is what it's about, is social engineering, and it's about confidence and making sure that developers have confidence in their CI server. If you don't have confidence in how you're testing, essentially what happens is that you forget about the unit tests you have, and it's running on Jenkins, or it's running on the Xcode server, and it's been broken for the last 6 months, and it's all red, and nobody's done anything with it. So really what I'm trying to do is think about your code metric and try and increase it all the time. I see some knowing nods there. Yes, yes, we'll all be there. But basically what you're trying to do is you're trying to make sure that your developers have a level of confidence in what you're doing with your CI server and with your stack, with your Agile stack. And if they do, that's great, because the peer pressure gets a lot of people on board, and basically you get better code coverage over a period of time. People know what the rules of engagement are. But if you don't start doing this, basically what happens is that it just falls off the cliff. Nobody really cares about it, and then you may as well not be doing unit testing. So, and the other thing as well is that if you do unit testing, you put it in the CI server, you can send all those reports to all those managers who ask you all those questions every week, and you don't have to worry about it anymore because you can automate this. And essentially that's what we're trying to get to, remove the bottlenecks. Okay, we have all the basic in Swift, the same as what you would be expecting in Objective-C, all the same unit tests, all the same assertions, I mean. If you want to enable code coverage, I think code coverage is very important. I'm not a metric Nazi at all. I think that what you should do is you should adopt the metrics that make the most sense for you. This is the first one you should probably adopt, which is code coverage. Check the checkbox for gather code coverage. And then we can take it from there. You can look at it within Xcode if you just want to see what the code coverage looks like, and it's pretty obvious what's covered here. I have one test for adding, and I haven't done anything for the subtracts. That's okay if you're a developer and you're working within the environment, but what do you do if you're actually somebody who's trying to look at it on the Continuous Integration Server? So for that, I use Slather. There's other tools out there too as well. Slather's great, it's pretty easy to set up. So basically what you have to do is install Ruby. Make sure when you install all these things that you're installing them as the Jenkins user. And don't install them as the local user. If you use RVM, you're going to run into trouble, because what's going to happen is that the Jenkins user won't have the permissions to be able to run Slather. So do a brew install instead of the RVM, which is the Ruby version manager. Gem install Slather, and then you can run Slather and output as HTML, whether it's a workspace or a project. Pretty straightforward. There is a little trick if you're running in Jenkins, and I'll show you at the end, that you have to have a slather.yml file to make sure that a YAML file to make sure that it knows where it should be slathering. And then it's pretty straightforward, and that will give you the code coverage. And you can use that within your reporting, and anybody who wants to find out what's going on can very quickly just go to log on to the Jenkins server and find out the information. So Postman. So Postman's great for just doing fairly simple API calls. This is for the sample app that we have at the end, which is called ETA Detroit. Detroit being the Motor City, it basically has the world's worst public transport system. No surprise there. We have 3 transport systems that don't talk to each other. So what we did was that for a competition, we reverse engineered the 3 different apps that we could find out there, put the information in an API server, and then we just do some API calls to say, we want to make sure that the stop ID, when we call the API, is the stop ID it's supposed to be. We want to make sure the stop name and the timings are the things that are supposed to be there. Okay, and then Newman is cool, because really one of my goals, another goal, is I want to make sure that everything runs from the command line. And if it runs from the command line, I can install it in Jenkins in a couple of minutes. I don't need to worry about plugins, I don't need to worry about plugin versions. I just do an execute shell, and then I can run it. So in this case, when I'm doing my API testing, what I'm doing is, Newman is, and I have all the URLs and the resources at the end of the slides. Newman is from the Postman folks, and it will basically run an exported JSON file for all your tests from the command line. It gives you kind of a exe pretty type output for whether the test passed or failed. And if they failed, you don't continue with the build, somebody gets emailed, and then they can go fix whatever's broken. XCUI, do people like XCUI? I think XCUI is the bomb, especially if you're starting off and you haven't done this stuff before. If you want to just do some fairly simple tests, even if you don't have to know how to write XCUI, it will record the tests for you, and then as a programmer, you can find out pretty quickly how the tests are put together. Basically, there's 3 parts. There's launch the application. You do an XQuery path type call to find the elements that you want to do any actions on, and then you do the actions. And then after that, you do the assertions. But once you've run it a few times, you see how the XCUI recording puts stuff together. It's pretty straightforward to be able to get this going. Haven't had many problems with, you'll see here it's doing just clicking on buttons and making sure that it's supposed to get the right response. Actually, I think I'm running it on the next slide. So in this slide, I'm doing XCUI to launch the application. I'm tapping on a couple of buttons, just making sure that whatever I tapped on gives me the answer 14 that I'm expecting. So with all assertions, it's arrange, act, and assert. So I'm arranging, I'm launching the application, I'm acting, I'm tapping the buttons, and then I'm asserting the number. Is 14, which is what we expect it to be. One of the things that we find that's pretty cool too as well is a lot of our QA folks really glom onto the XCUI really quickly, and Selenium and any of the automated tests. We find out that our QA folks, probably about 80% of them are developer wannabes, which was a real surprise to me, but it works really well if you're trying to get this up and running. So what we're trying to do is get less and less manual tests. And if you can do even something like XCUI, so you can run through your app, run through the happy path, put that into the Jenkins server, you're already going to catch, a significant number of defects as the app is developed over time. One of the downsides on GUI tests is they are very brittle. So for example, if you have a login screen and the login changes because you add an email field that you hadn't before, or you move the button, then the tests can fail. So if you remember back to when I had that pyramid at the start, the GUI tests were a smaller number than the unit tests, and it's set up that way. My code was basically trying to show us that we should be writing more unit tests than we should be GUI tests. Does that make sense? Okay, so this is why I do GUI testing. So this is the main reason, because we have engineers, developers who love to write unit tests and never write any functional tests or integration tests. And what happens is each part of their app is working independently perfect, but the big picture is lost. So a lot of the times we'll write 1 or 2 XCUI tests just to make sure that the big picture isn't forgotten when we're moving across and we're testing around. Okay, so now that we have our stack of XCTest, API testing with Postman, and we have our XCUI, we want to put it all together and we'll put it into Jenkins. So we have just a simple hello world here where you would set it up with the GitHub. You would use your build triggers, so your build triggers would be, I don't know, whether each night, if you want to set up a cron job within GitHub, or if you want to do it every time somebody checks in the code. And well, let's walk through this. This is the Cuckoo is my girlfriend website. So this guy talks about setting up Jenkins CI on a Mac. It's 2-3 years old now. I think it's 2015. Yeah, it's 2015. So it's old now. So this has been around for a while. But this works. At the end of it, he says, as he talks about how you should set up Jenkins, I think this was written for Jenkins 1.x, but it works on 2.x as well. But at the end he says, cross your fingers and hope that it all works, but every time that we've used this, we find this to be very successful. What it basically does is it sets up Jenkins as a Jenkins user on an independent box, so whether that's you have a Mac Pro or if you have a mini Mac or whatever you want to do to set this up. We use Mac in cloud, so basically we just use one of the Mac servers in the cloud. You can do master slaves, you can do all sorts of different things, but we try to keep it as simple as possible in order to be able to make sure that we remove as many things as could possibly go wrong with Jenkins, because my God, they do. So you gotta make it as simple as possible so that Jenkins can be reliable, because that's one of the things that we're trying to do over a period of time. Here's a list of things that you want to do. I'm not going to walk through this, but I just wanted to put this up in the slides. So basically what I've done is just taken all the important steps that you need to take care of. Essentially what it is setting up Jenkins as its own user, so that every time that you log in, every time that the software gets updated, it's still going to log in Jenkins automatically. And there's a couple of really weird arcane things that you have to do at the end to edit a plist file, stand on one toe and jump up and down, this kind of thing. But this actually works, so it's great. So we can now have a reliable way of setting up Jenkins on multiple boxes as many times as we like. Let's talk about first principles. So in Agile Swift, in all Agile testing, we have first principles. We want to make sure they're fast. So the reason we want to make sure they're fast is because if your unit tests and your testing takes way too long, what's going to happen is that people are just not going to run them. So you got to make sure that they're lightning fast. You got to make sure they're isolated. You want to make sure that the tests don't fail because the network went down, or the tests don't fail because the web service has changed. That would be a different type of test. You want to make sure your unit tests are isolated from any outside influences. You want to make sure that they're repeatable. You want to make sure that you can put them on a continuous integration server, and that each time they'll run. So a lot of times when we've done GUI testing in the past with Cucumber, we found that there's been a lot of problems where the test failed for no apparent reason. So a lot of the times the reason that happens is because for the computer that you're using, is the CPU's gone through the roof. The user interface doesn't fire up as quick as it did before, and then your test fails because whatever wait statement you had in there wasn't waiting long enough. So you got to make, if you're using something like XCUI, we don't have a lot of wait statements in there. It's a first-party library. It's an Apple library. It works much better, and it's much more repeatable. And then self-verifying, that's where it gets back to code coverage again. So if you're using code coverage, you want to make sure that everybody knows that the code coverage is at an acceptable amount, so that you know that when you do a new feature, that the tests, that any changes that you have, the tests are going to protect you from any of the weird side effects that you might get from the changes that you've made. And the last thing you want to talk about is timely. So when do you write your tests? Do you write your tests the day before the Scrum is finished? Do you write your tests 6 months later? We have a lot of apprentices that come in that we train all the time, and one of the things that we do with them is that we ask them to do an app, and then we ask them to get some insane code coverage number, like, I won't say 98%, that's really cruel, 80-85% after the fact, and it's really difficult to get your unit tested code coverage up to an acceptable level if you're not writing the unit tests when you're writing the code. Test-driven development for me, I don't necessarily insist that somebody writes the test first before they write the code. That's quite difficult when you're using kind of a mobile environment like Xcode and the storyboards. But what I do encourage people to do is to write the unit tests around the same time as they're writing their code. The reason for that is twofold. One is, like I said, it's really hard to get your unit test code coverage up to any acceptable level 6 weeks after you write the code, even 6 days afterwards, even sometimes 30 minutes, because you've forgotten what you were writing about. You've forgotten what feature you were trying to implement. You have to remember where you were before. So your unit tests are often inappropriate if you write them not at the same time as you're writing your code. Does that make sense? We find that we get much better unit tests, much better appropriate unit tests, much better code coverage if you write them the same time as you're writing your code. So fast. So the definition of fast. Basically, no outside influences. This is taken from a Google blog in 2002. It was about the web, but it applies to everything else. So what we were trying to do is no network access, no database access, no file system access, no threads, no sleep statements, nothing about system properties. And the way we do that is mocking. And mocking is quite hard in Swift because Swift doesn't allow you to do dependency injection on the binary, so you have to have this two-stage process. There are other ways of doing it as well. The way that people use protocols and extensions all the time. We tend to use Cuckoo, which is a pod that I found very useful over the last 16 to 18 months. And basically what that does is it gives us a way to mock out any of our tests, any of our database calls. And I'll show you how we do that in a second. And then fast, the other thing as well is that we can measure the performance of our unit tests using measure blocks. So we can, if we have unit tests that we think are going to be getting worse and worse over time, we can put a measure block around it. When we run our unit tests, it's going to run the test 10 times and give us a baseline of where our tests are. So then we can see pretty quickly if our tests are getting slower over time. Very important because it's back to that social engineering thing, it's back to that peer pressure thing again. If your tests are starting to take 20 minutes, 30 minutes, 40 minutes, it's starting to get into an hour. If it's starting to get to the stage where you can only run them at night time, then you need to think about how you're writing your tests, because you're going down a slippery slope where you're going to, or somebody's going to come along and say, hey, why don't we run unit tests anymore? Oh, they took too long. It's really easy to get there. So have something in place so that you can measure how long your tests are taking, and make sure that somebody is responsible for following that metric within the team, and rotate that person too as well. So mocking. No matter what language you're using is when a method is called, then return a value. That's the way that we use mocking. So basically what we're using is we're giving back a canned result. So in Cuckoo, basically we stub out each of the different calls that we have. So for example, we have when a rewrite property, when we get that, then we return this fake value 10. If we go and call a database, we're going to return our fake value John Doe. In the ETA Detroit app that I'm going to talk about, what it does is it goes out and calls an API to give us a list of the routes for a certain company. Now I know what those routes are. Those routes aren't going to change, so we can fake that. We can fake a series of stops, because really what we're trying to test is we're trying to test the code that we wrote. We're not trying to test the API code, not when we're doing our unit tests. We're trying to make sure that our parsing works correctly. So any of the code that you write after you do the API call is really what you're trying to test within your unit tests. So Cuckoo's, it's a bit hard to get up and running. I have a video of it, which I'll show you in a few minutes. But basically what you have to do is you have to have, you install the pod, do a pod init, install the pod, and then basically tell it which file that you want to mock out. And then it creates a generated mocks file, and you have to add that to, that's the two-stage process. You have to add that to your tests, and then basically you can run your tests against that generated mocks.swift file. So that's where there's a run script that we have to install. The run script looks like this. So basically, it's up on the GitHub. You pull it down. You make sure that you point it at whichever files that you want to mock out, and then you take it from there. So this is a lesson learned. First principle is repeatable. We have found, I don't know, many times this has happened, that somebody has got the build to work on Jenkins, and the way they've done it is they've SSH'd or telneted into the Jenkins box. They've made some change. They've added some environment variable which isn't within Jenkins, and they've got the test to run. So 6 months later, 12 months later, 18 months later, when you're doing version 2, version 3, you don't know how that ran in the first place, because somebody made an environment-specific change. You moved it to a new Jenkins box, you've got a bigger box, you don't want to use Minimax anymore, you've decided to go to Mac and Cloud, and you don't know how to do this. So what we always insist is either before or after each of the builds that we delete the workspace. And that way we always make sure that anything that we're building within Jenkins is within the environment that we have within Jenkins that we've set up, or it's something that's in GitHub that's pulled down when we run our Bitbucket or whatever source code control system you use. So one of the examples here was that somebody FTP'd a Slather.yml file up onto the box, and that's how they got Slather working. And we couldn't figure out how to get Slather working until somebody went look at the workspace and said, oh, there's an extra file here, it wasn't supposed to be here. So just make sure that you do this. So you delete the workspace either before or afterwards, and it will save you a lot of hair pulling when you go around to do it again. Self-verifying. Okay, self-verifying. Code coverage. So this is not from an iOS project. I am not getting 99.2% code coverage. You should be aiming to get whatever you think is plausible. Between your unit tests and between your GUI tests, if you're getting 70-80%, that's a really good place to be. If you're getting 30-40%, you need to start working on getting that up something closer to the 80 or 90%. If you're getting 99%, you're probably doing a lot of things like reflection-based things, or settings-based things, which for me just don't seem to be the right thing to do. So basically, the reason that we're doing this is not to get a code coverage metric of 99.2%. The reason we're doing this is because our customer wants to have a good app that isn't failing. So whatever that metric works out for you, just make sure that you as a team are comfortable that we introduce new features, that you're not going to have any weird side effects. And then timely, so if you're doing test-driven development, you write a failing test, make the test pass and refactor, like I said before. I don't really insist that people do this at the same time, but you should be thinking about writing your unit tests around the same time as you're writing your code. Certainly not at the end of the Scrum, because the Scrum Master has told you that's what you got to do. As my brother, who's a .NET developer in Dublin, tells me wherever there are Scrum Master or Scrum slaves. Like I said, what we're trying to do is not get to that situation. We're trying to get to a situation where everybody's working in a corporate environment, in a creative environment to create better software, quicker, faster, better. For me, I find this as being very useful. I also find pair programming really useful. And it's really difficult to do it in a services environment because people find that they're paying for the code twice. Now, as a business owner, I'm saying that pair programming is great. The main reason I'm saying it's great is there's no procrastination. There's no Facebook. That peer pressure is working in our benefit so that people are working and they're working together, having less defects. And they're also working together faster and a lot of our developers are very creative and have that ADD mindset, and their mind just goes elsewhere. Pair programming is a great way to make sure that we all keep on track. Not that a lot of our customers agree with us in a lot of cases, but really that's what we try to do, by and large. So this is our sample app. So it's called ETA Detroit. Basically what it does is there's a bunch of different companies that, so there's Smart is in the suburbs, there's DDOT that's in the city, and then you have a couple other fast buses and people movers, which is our magnetic line. And then what we do is we just say, okay, tell me where the list of routes are, tell me the list of stops, and then tell me what the times are. I just skinnied it down here for purposes for a sample app purposes. So it goes Smart, DDOT, and Reflex, and then you click on them and you get northbound, southbound, eastbound, westbound. And that's what we're going to test. So if you want to do a unit test, what we want to make sure is we're testing our JSON parser. So we're testing our JSON parser, we're pulling back some fake JSON that we got from our Cuckoo mock, and it's basically saying the route name is 4th Street, Eureka, the direction is northbound, southbound, and the route ID should be 125. If you want to run your unit tests on the command line, basically what you do is you do Xcode build test, and you just tell it that you're running the mock tests, which is the directory within Xcode, and then we have ETA mock UI tests, so that way we can separate our unit tests from our GUI tests, and also if you're building it, you do Xcode build. So our sample unit test, and now we take our generated mocks, our build script, we say that we want to fake out the JSON fetcher.swift. I'll just run this real quick. A lot of people don't like our approach because it seems to take, because it's this two-stage process. Are you mocking a lot? Like there's no OC mocking anymore. What are you doing in Swift? How are you guys managing this? Or are you just not doing it? Just fake it? Just create stubs yourself?
Yeah, just can't roll it.
Have you looked at, has anybody played with Cedar or any of those frameworks?
Yeah, I've used Cedar on the projects.
Is it good?
If you like C++.
Okay, yeah. And a lot of people use protocols and extensions to do this, but I have this weird thing that, and basically what it's doing is we're commenting it out and then we're going to run this so that it runs the build script and creates the generated mocks.swift and we build this in. But I have this weird thing about when I write code is that I don't want to change my real production code just to satisfy my tests. I think that's kind of bass-backwards, it's like I don't know why we should be doing that. So really what I try to do is try to use something like these mocking frameworks, or just the same thing as well, just stuff it out ourselves. See, so you could do this by just stuffing the file and just returning a fake JSON string and run it from there. But I wanted to show how to do it using Cuckoo. This is up here as well. So if you do want to play with Cuckoo, what I would recommend is, because it's kind of that two-stage process, it can be a little fiddly, a little bit awkward to get going. But if you look at the video and show how we did it, it's pretty straightforward how you can follow the steps. If you follow the video, you can get through it. And then if we do an API test. So this is our API. So our API here is just returning all the routes for company 3, which is Reflex, which is the smallest. That's the fast bus. Then we have our API test, which is what we showed before. We've got to make sure that the stop, the route, and the number is the same. Go on.
So you guys don't introduce abstraction as for code testable. It is testable. Now, don't introduce new protocol just
some of our developers do. Personally, I think we're changing a lot of the production code just to satisfy the test, and that to me smells. It's a code smell to me. It's a matter of opinion, really, more than anything else. Some of our developers definitely do. They think that Cuckoo is a step too far because you have to do the 2 steps. But that's kind of, it's up for debate at the moment, really. I don't think there's a better framework out there that does it, other than writing protocols and extensions. There's a really good WWDC from 2015 that shows how to do that, if you want to follow that route too as well. And then Newman, if you want to run it from the command line, because that's what we're trying to do, run it from the command line. Okay, and then we have our API test. And then our GUI test. In this case, all we're doing is we're just walking through our sample app, say, okay, we're going to pick on Smart, we're going to pick on South Shore, we're going to pick Southbound, and we should be able to see the static text, Jefferson, Southfield. And then in the bottom, you can see I'm doing Xcode build test, and I'm just focusing on, I'm only testing the ETA mock UI tests. So put it all together. So now we have, at the start, I just do a pod install. This is after we've deleted the workspace. I'm doing my unit tests. I'm doing the API tests. I'm doing the GUI tests. And then at the end, we just build the app. So back to the original framework, the original pyramid that I showed, XCUI, Postman, and XCTest. So if you want to get that running in Jenkins, the way to make sure that everything's working is you set it up the way that I just showed, and then you go to see the console output. The console output will basically tell you how everything's running, whether it's working or it's not working. Then you want to introduce Slather, so you need a Slather YAML file, which basically just tells it that you're using the prof data format. Coverture XML, it's the same for us each time. We want to create a Slather report and tell it where the scheme, the workspace, and the Xcode project is if you need to. And then we run Slather, we just basically run the Slather command. So we're just calling it from user local bin. And then our post-build action is we say that we want to publish the coverture coverage report, and then it shows up within Jenkins. And over a period of time, we just did this 2 or 3 times, we ran the report multiple times. Over a period of time, you should be seeing your code coverage changing based on whether you're not writing unit tests or you are writing unit tests. It's great because then I don't need to talk to developers. I don't need to ask the question. It's up to me as a manager, as a Scrum Master, it's up to me as an owner to make sure that if I want to check in on something that I have a login for Jenkins, I'm talking to the DevOps person, I'm not talking to the developers and wasting their time. I can see how everything's going, so I can get my own feel about whether something's going the right direction or not. I love SonarQube. Only problem is it's expensive on Swift, so it's $5,000 on Swift where it's free on everything else. Hopefully that changes over time, or we can find a cheaper alternative, or maybe there'll be an open source Swift for SonarQube. But SonarQube, basically, the reason that I like this is because we have had issues in the past with code reviews. And the code reviews have been almost like an attack as opposed to trying to get better code. So SonarQube works really well because it allows the junior developers to be able to go in there and see what issues they have, and they know what kind of... Basically, SonarQube does static analysis of all your code against a bunch of rules that are defined and that you can add to. So in all those rules, they can basically see the type of things that somebody would pick up in a code review. So as a junior developer, they can go in and see the issues, look at the critical issues, look at the major issues, and fix them without having to ask anybody. So we just put this in as our definition of done. And that allows the junior developers to be able to get to a code review stage where you're not talking about the right thing in code reviews. You're talking about architectural things. You're talking about the type of things of what's the design pattern that you're using, not silly things because you didn't format the code correctly or you didn't use whatever template code we were supposed to use. The other thing that works really well for the more seasoned developers is because if they have something that they really want to see in the code, that they can write their own rules and we can make sure that they're added, assuming that the team agrees. You can add all sorts of things to Jenkins as well to get rid of those silly arguments. So you can use SwiftLint to make sure that it's formatted correctly, tabs versus spaces. Let's automate this so we're not having silly arguments about what the code should be. And as a business owner, the reason I love this is because it allows me to dig into the code and see weird things. So, for example, when I see that there is an empty method, I'm going, why is an empty method? So it allows me to ask more appropriate questions rather than say, how's everything going? So it allows, as a manager, as an owner, to get a better feeling of how the code is being developed from a technical perspective as opposed to just from somebody saying, it's got great, yeah, you've got great code coverage. You can see what the rating is. So if the rating is a C, you know that you've got issues. You can see what the technical debt is. So if you can see what the technical debt is, you can see that somebody has to tidy up the code. We give our code out to, we don't own the code because we're services, so we give the code out to the client. A lot of times, other services company will try and come in and take the work, and they'll do a code audit for free. This safeguards this because all the silly things that they've been complaining about, say, hey, see how bad they're doing this. This will allow us to fix that. There's Coverture as well, there's a few other ones out there. And then to run it in Jenkins, there's two parts. There's a scanner, so you have to set up a scanner, and there's a website, and it basically just links to the website. Okay, and then there's no reason, if there's anybody doing any server-side Swift? There's no reason why you can't do that on the server-side too as well. If you want to see how it's a little bit more difficult to set up because you have to write the package Swift and the Linux main .swift file, but once you've written it once or twice, it's pretty straightforward. It's just a bit of extra code. If you run Swift package in it, it will create a hello world for you, so you can see what the format's supposed to be. So that's a good way of checking to see how the test framework should work on the server side. And then if you want to run your tests, you run Swift test or Swift build if you're trying to build it. And it's the same sort of output, so it's exactly the same engine as you would see in the logging when you look at the logs within Xcode. Okay, there's a whole bunch of URLs. So I put a lot of this stuff up on the blog. It's getting a bit old now, but we do make changes. So we're starting to do much more Fastlane now. So a lot of this stuff, the reason that we did this at the start was that basically what we were trying to do was use Jenkins to automate everything. So it wasn't one person who knew everything, and if they left, then we were in trouble. So we're trying to codify this automation. Fastlane, we're finding, is really good for setting this up. So once you've done it once, and if you create the lanes within Fastlane, it will set up a lot of this for you. It still doesn't get over some of the headaches you have with Jenkins. And Fastlane is really more focused on the deployment stage, as far as I can see, but it does work for this too as well. There's URLs for Postman, for Newman, for Cuckoo, for Jenkins. That's the URL for Cuckoo is my girlfriend, the sample app that I have, the slides, SonarQube, and then Fastlane. I think this is all going to move to Fastlane, if not now, pretty soon. And then just some contact info, so the two books. I love to talk about the stuff, so if anybody's got any tools that they would recommend, I'm more than happy to look at them and start them on the next blog. So any questions, because I think we're just about out of time. Is that useful? Did I bore you to death? Are you going to use it? Are you going to take it back? I tell you, it's a lifesaver for me.
Are you using unit testing to test views?
No, I do. That's a really good question. Am I using unit test to test views? No, that's what GUI tests are for. Take your code and move it out and put it into Swift files and unit test it there, into model files.
How do you separate your integration tests and your unit tests?
Well, integration tests for us are basically what we do is we mock out any of the integrations. So we mock out any of the dependencies that we have on external things. And basically with integration tests, we mean like API testing, or what else are you talking about?
Specifically API testing.
Yeah, we just use Postman for API. So there's a distinct separation between GUI, the API, and the unit testing. The unit test, we don't do any API calls within the unit tests. So we will only do our API calls. So basically we'll fake the data coming back using the mocking from using Cuckoo, and then we'll test whatever test code that we have, or whatever our code is, and then our API tests are all run within Postman. Although we're really doing a lot more on rest assured now, so it would be either or. Thanks very much, guys. Hope you enjoyed.